Hi guys, this is Amar and welcome to Network Engineer Stuff. So guys, in this video, we are going to focus on BGP interview question and answers advanced part 1. Question number 1. What are the BGP timers and why BGP hold timer is high as compared to other routing protocols? So guys, you may be aware of default BGP timers. So the default BGP timers are keep alive of 60 seconds and the whole timer of 180 seconds. 180 seconds means guys 3 minutes. So which means that let's say R1 and R2, these are the BGP routers or BGP speakers, and they have let's say a BGP session established between them, BGP neighborship established between them. So they will send keep alive messages to each other every 60 seconds. And when we say the whole timer is of 180 seconds, that is of 3 minutes, it means that even if the BGP does not receive any message from a neighbor for up to 3 minutes, it will still keep the session up. Let's say R1 is not receiving, does not receive anything, any BGP message for from R2 for 3 minutes. Still, R1 will keep this BGP session, this BGP neighborship up. Of course, after 3 minutes, it will put it down. So, this is the behavior of BGP, or this is something, the timers of BGP we talk about. But now this timers, or the question is like whole time. Why the whole time is of 180 seconds? We compare it with, let's say, with OSPF. In OSPF, the dead timer is 40 seconds. But in BGP, it is 180 seconds. So if we compare this, there's a big difference. 40 seconds and 180 seconds, a big difference. Why it is? BGP actually does not react quickly, to the network changes. Which means, okay, if this link between let's say R1 and R2 goes down, this is R2. If this link between R1 and R2 goes down, if we have let's say OSPF, a neighborship between R1 and R2, after 40 seconds, the neighborship will go down. But in case of BGP, it will take 3 minutes for the neighborship to go down. The question in the interview is this: why is the whole timer high? The answer to this question is that by design, BGP is designed to be a slow protocol. Because basically the BGP is designed for stability and not for the speed as the other routing protocols, other IGPs are designed. Now, why it is designed to be slow protocol? Why it is designed for stability? The answer to this question is that, as guys you know that BGP is the protocol of internet. BGP is the only protocol in this category of EGP. Okay, exterior gateway protocol. It's the only protocol. So it's a protocol of internet. Okay, like our IGPs, they operate within single AS. They are intra-AS routing protocols, where BGP is inter-AS routing protocol. BGP connects thousands of ISPs, enterprises, DCs across the global internet. So BGP is designed basically to handle millions of routes. Okay, so I've mentioned here that BGP is responsible for exchanging millions of routes. It is responsible for routing critical internet traffic. So imagine if BGP was quick protocol or fast routing protocol, anything changed will impact the global routing table, which is GRT, which is the routing table of internet. So it will impact that. It has been designed such that it will be a slow routing protocol, because instability in BGP cannot be afforded. So that is the reason why BGP is a slow protocol, and that is the reason to design it as a slow protocol. The whole timer is kept by default as 180 seconds, that is 3 minutes. So guys, we can give this answer like this. this is a bit a tricky question, or a question which would require some understanding, good understanding of BGP. So let's move to question number 2. Question number 2. What is the difference between update source and next hop self in BGP? So update source and next hop self. So these are the two different, I'll say, concepts in BGP. Update source, guys, is basically used to ensure that the BGP peer uses loopback interface as the source instead of physical interface. So what does it means? Let's say we have two BGP speakers, R1 and R2. Okay. So whenever they're trying to establish neighborship, of course, they'll send some messages to each other. So that the message, okay, the source of that messages by default is a physical interface. So let's say this is physical interface serial 0. So by default, the source will be serial 0. But in multiple cases, like if we have seen, we use loopback interfaces. Now let's say R1's loopback is 1.1.1.1 and R2's loopback is 2.2.2.2. So whenever we are configuring in on R1 the neighborship for R2, we will configure it as like neighbor 2.2.2.2. Okay. So whenever we configure like this, so by default, that BGP packet or the BGP message will be sourced from the serial 0. Now, since we are using loopback interfaces of each other, again for R2 also we will use the same command. Okay. So we have to mention that the source here is not the physical interface, it is a loopback interface. So we have to use this command, update source loopback 0. So on both the end, you have to configure it on R1 as well as on R2, so that the packet will be sourced, the BGP packets will be sourced from loopback interface and not the physical interface. And since we're using loopback IPs for establishing BGP neighborship. So this is, guys, one concept. The other concept is next hop self. Before using this, like the question will come to you like related to this next hop behavior in BGP. This question is very common question. I won't say that this is a bit an expert level question or something, but yeah, a very common question. And of course, in most of the interviews, this question is been asked. So this is a very important thing. So that is the reason I have mentioned here in this particular video also, that is what is next hop behavior in BGP. So whenever you are giving an answer related to next hop self, so it's better that you explain first that what is this next hop behavior in BGP. So what does this next hop behavior in BGP says? That by default, now this is a default behavior, when a BGP router sends an update to its eBGP neighbor, its next hop will be itself. And when a BGP router sends an update to its iBGP neighbor, its next hop will not change. Its next hop will not change. So this is the next hop behavior in BGP. Let's say this is router R1. This is router R2. Now they belong to the same AS. Let me draw it. Okay, so they belong to the same AS. So the neighborship will be between them. The BGP neighborship will be iBGP. And let's say there is another router R3. This is in some different AS. So here the BGP neighborship will be eBGP. Now let's say R3 have some route 100.1.1.1/32. R3 sends this route to R1. Now on R1, in BGP table, this route will get installed 100.1.1.1. And the next hop will be next hop. So the next hop will be R3 only. Fine. The next hop will be R3. Now, since it have the R1 have this in its BGP table, it will also install in its routing table. Since R3 is reachable from R1, the next hop, once the next hop is reachable, R1 will install that 100.1.1.1/32 route in its routing table. Now, when R1 will send the same route to R2, in R2's BGP table, the route will get installed 100.1.1.1/32, but the next hop will be R3, because our next hop behavior says that when a BGP router sends an update to its iBGP neighbor, its next hop will not change. So it is not changing. When R1 is sending the route which is received from its eBGP neighbor R3, it's not changing the route when it's sending it to an iBGP neighbor R2. So R2 is not going to have reachability to R3. So since it is not going to have its reachability to R3, the next hop is not reachable, R2 will not install this BGP route in its routing table. So there will be no entry in the RIB, correct? So what can be done is to use this next hop self command on R1. So what we'll do in R1 is, for this neighbor R2, we'll tell that next hop self means when R1 will send an update to R2, to its iBGP neighbor R2, it will keep the next hop as itself. So the next hop will be R1, and since R2 will have the reachability to R1, its next hop will be reachable. It will be of course installed in the routing table. So that is what the next hop self is. So it changes the next hop IP of its own next hop IP to its own IP. So this is what R1 is doing over here. Now this plays significance only in iBGP. Okay. Let's move to question number 3. BGP session is stuck in active state. What could be the issue? Now, this is a very common question, that BGP session is stuck in active. So guys, whenever we say BGP session is stuck in active, active is bad in BGP. It is not good. Active means down. The BGP session is down. So what could be the probable reasons? Now, many of the people are aware of this answer, but in interview they are not able to structure the answer. Okay, so let's structure this answer and put it in points. So the very first reason would be that the neighbor reachability issue. The neighbor itself is not reachable. Let's say we have this R1 and R2, the IP of R1 is 1.1.1 and the IP of R2 is 2.2.2.2. So from R1, if this particular IP 2.2.2.2, the IP of the neighbor router itself is not reachable, the neighborship will not form and the neighborship will be stuck. The BGP session will be stuck in active. So this is one of the reasons. The second reason will be that BGP peer not configured correctly. Now this happens. This is something a manual error or manual mistake, which is done by most of the engineers when the configuration is huge. So you can check this part also, and the command to check this BGP configuration is show running config pipe section BGP. Show running config pipe section BGP. So it will display the BGP configuration, and then you can just check whether the neighbor IP is correct or not. In this case, the neighbor 3.3.3.3 is not correct. It should be 2.2.2.2. So in interview, guys, you can mention this particular point also, and in interview, it's better that you also try to explain it with some examples, with some this commands like this, which I have mentioned over here. Okay. The next reason will be incorrect update source interface. So in case like as we have seen in the previous question, the importance of this update source. If let's say this update source command is not used, we are configuring BGP neighborship using loopback interfaces between these two routers, and we are not configuring itself update source, then the neighborship will be in active state. It will not come up. Okay. So the update source command is very important. You need to configure it, you have to check it whether it is configured or not. And if it is configured, you have to check it whether you have mentioned correct interface or not. Like here I have mentioned loopback 1, which is incorrect. It should be loopback 0. So this is again one of the important point. The update source commands need to be present if you are using loopback interfaces for BGP neighbor establishment, and it should be correct. The interface should be correct. The other reason will be I'll say a firewall or an ACL blocking a TCP port number 179. Now guys, most of the guys will be aware that BGP uses TCP port number 179. Again, this is a separate interview question, but not an advanced level interview question. But yeah, guys, you must be aware that the BGP uses TCP port number 179. Now, let's say for some reason between those routers there's a firewall present. Between the BGP speakers, firewall is present. So, and your neighborship is stuck in active. So you can go and check on the firewall whether there is any rule in the firewall blocking this particular port number 179. So you have to check it. The other reason will be an ACL present on the router itself. I've shown here an example. Like by this command, you can check the ACL, show access list. So here is the ACL, and this ACL is basically blocking. You can see here this ACL is basically blocking to this particular host. It is blocking this port number BGP. BGP, this means 179, okay. This means TCP port 179. Now, how will you know? The interviewer may ask you that, okay, fine, but what is the command to check whether that is getting blocked? The TCP port number 179 is getting blocked. So there's one command, a debug command. Of course, it's in debug command, so you don't have to run it in the production network. But still, this is the command debug IP TCP transactions. So this command will show what all the TCP transactions are currently going on the routers. So like here I have shown one example, like so this router R1 is sending sync to 2.2.2.2 on port number 179, and it is getting timed out. So of course this TCP port number 179 has been blocked somewhere. Let's move to question number 4. This guy's question is very interesting, and this is a question, I'll say, of course asked to experienced guys only. A very good question, and guys who have good understanding of BGP, they only can answer this particular question. That you are receiving a BGP route in BGP table, but it's not been installed in the routing table. So we have this on the router, the BGP table, something known as BGP table, which will have all the valid BGP routes. And of course, each router have something known as the routing table or the RIB, which will install the best route to reach the destination. So the question here is that some route is that the route is present in the BGP table, but it is not getting installed in the RIB. What will be the possible reasons? The first reason will be the AD preference, the administrative distance. Now, guys, you know the administrative values for BGP. For eBGP, the AD value is 20, and for iBGP, the AD value is 200. Now, if that router is having, let's say, it have for this network, let's say 100.1.1.1/32. Okay, if that router is having entry in BGP table, okay, and it is learned via iBGP. So for this route, the AD value for this route in BGP, since it is learned via iBGP, the AD value will be 200. And the same route is being learned via OSPF, for which the AD value is 110. Of course, the OSPF learned route will be installed in the RIB. Since OSPF is having a better AD value, lower is better. As I've shown here, like show IP BGP, you can see here this particular route, it is installed in BGP table, but if you go and check the routing table for this particular route, okay, it has been learned via OSPF because of this AD value. The second reason will be that next hop is unreachable. Now, it happens that you have a route in BGP table like here, okay. You have a route in BGP table, but this next hop 192.168.100.2, now this particular next hop is not reachable. Now, it should be made reachable via some IGP or some static route, but let's say it is not reachable. So, if the route is not reachable, it will not get installed in the routing table. Even if it is present in the BGP table, it will not get installed in the routing table if the next hop is not reachable. So, this is one of the reasons which I have mentioned. Reason number 3, iBGP route without next hop search. This is something which we have already seen in this particular example. I think, yes, in this particular example, we have already seen it. It was in question number 2. Yeah, this particular example. So here also, like, R2 was having the next hop as R3, and the next hop was not reachable. So that was the one of the reason why it will not be getting installed in the routing table, even if it is present in the BGP table. Reason number 4 will be that the prefix has been denied by some policy or by some route map. Any inbound or outbound route map, prefix list or filter, okay, may accept the route in BGP, but preventing installing in it RIB. So, in case there is some, let's say, some route map, I've shown an example of a route map over here. Okay, so this is basically blocking this route map have this prefix list, deny a prefix. This prefix list have this particular route, 100.1.1.1/32, and it's been denied. So maybe there's some route maps which are blocking it from being getting installed in the routing table. So we have to also check that part. So whenever this question is asked, guys, that the route is been getting installed, been getting received in BGP table, but not getting installed in routing table, you can mention a few reasons like this, and I'll tell you that these are the great reasons and these are the practical reasons why the route is not getting installed in the routing table. Guys, I do have multiple questions ahead, question number 5 and more questions, but I think I don't want to make lengthier videos. I'll cover this questions in the next part 2 of our series. So guys, I'll stop here. Now, before stopping, I like to say that we do have one email address on which you can write me. You can give your feedback on this particular email address. If you want any notes or any help, you can of course mail me on this particular email address, that is networkengineerstuff@gmail.com. We do have a WhatsApp number also, 8828002605. If you wanted to have some mock interviews, or you wanted to get your CV reviewed, we can do so. You can message me on this number, on both this email and on this WhatsApp number. I do respond, and many subscribers do mail me and WhatsApp me their queries, and we get in touch. So, guys, I'll stop, and I'll catch up you in the next video. And of course, in part number 2 of this interesting advanced BGP interview question and answers. So, guys, I'll stop. Best of luck, and bye. Thank you.